we're going to go ahead and talk about equivalent fractions. Okay, just a fancy way of saying, okay, fractions that represent the same amount, just written differently. All right, so if you look here, I have a circle. Okay, so what fraction of the circle is shaded in? Well, 1 out of 2 pieces, so a half. Okay. Okay, so that's one way of writing this amount. Okay, what happens if I do that? Okay, what would the fraction now be of the shaded amount? Okay, well now there's 2 out of 1, 2, 3, 4. 2/4. Okay, do these fractions represent the same amount of the circle? Yeah, it's the same amount, they're just written differently. Okay, let's go like this now. Okay, so what fraction would represent the shaded area? Well, now we got 1, 2, 3, 4 out of 8. 4, 8. Okay, and I can keep drawing lines and drawing lines and drawing lines forever, but they all represent that same amount. I've just written them in different ways. Okay, these three fractions are equivalent. They represent the same amount. All right. So we're going to find a way. So in your assignments, they're going to ask you like to write two fractions that are equivalent to the one they give you. So say 1/3. Okay. What are some fractions that would represent the same amount of that? Think that circle, a third shaded in. Okay, draw some lines. What would be some fractions that would represent the same amount? Okay. Well, the trick with this is, there's unlimited equivalent fractions. They could go on forever. But how, the best way to do this is, okay, well, 1/3, let's go ahead and double it. Okay, so if I do that, okay, 1 times 2, that's 2. 3 times 2, that's 6. Okay, we've doubled it. 2, 6, that's the same as 1/3. Okay, maybe let's triple it. Okay, well, 1 times 3, 3, 9. Okay, so as long as I'm multiplying by the top the top and the bottom by the same number, I'm going to get an equivalent fraction. Okay, and then I did it for 3 ninths. As long as the top and the bottom are being multiplied by the same number, the fraction I get will be equivalent to that fraction. All right, let's do another. Let's do 5/6. Okay, so two equivalent fractions of 5/6. Okay, well, we can do, well, let's do times 2. Times 2. 10, 12. Okay, again, multiplied both by 2. Okay, well, let's go ahead and do 3. That's pretty easy. All right, so that's 15. All right, so I have my 3 equivalent fractions. Okay, what happens if I have something like 12/18? Okay, so yeah, I can use bigger numbers. So I can like multiply by 2, multiply by 3, but I could also use the same idea with division. Okay, so maybe my equivalent fractions are smaller. Okay, so let's do, well, I know they're both divisible by 2, so let's divide by 2. Okay, so that'd be 6/9. Okay, still equivalent. Okay, let's do, they're both divisible by 3, so let's go by 3. Okay, 4/6. Okay, and so on. Okay, so these are all equivalent fractions. I could even do this one. They're both divisible by 4. So that would be 3. No, they're not divisible by 4. What am I doing? Oh, hold on. I think I did something wrong. 12, 18. Oh, I know. Oh, okay. Hold on. No, they're not divisible by 4, but they're both divisible by 6. That's what I was getting at. Okay, so that would be 2, and that would be 3. All right, so disregard the whole like divisible by 4 thing. That was an oops. All right, so these are all equivalent fractions. Okay, 12/18 represents the same amount as 6/9, which represents the same amount as 4/6 and 2/3. Okay, eventually you're going to get down to simplifying fractions. Basically, that's like putting 12/18 into smallest terms, put them in the smallest number possible that's still equivalent. So in that case, 2/3 would have been what they wanted. All right. Oh, and that's the next part of the lesson. So write each fraction in simplest form. So 10/35. Okay, so simplest form, so think, okay, well, are we going to be multiplying to make them bigger? Or are we going to be dividing to make them smaller? Simplest form, we want small. Okay, so think division. So look at 10/35, and this is kind of where that greatest common factor stuff that we talked about a couple lessons ago will come in handy. So kind of look at those numbers and say, okay, well, what's the greatest common factor? What's the biggest number that both 10 and 35 are divisible by? Well, you can think through, well, 10, does it go into 35? No, but I know they're both divisible by 5. So let's go ahead and divide both by 5. Okay, so 10 divided by 5 is 2. 35 divided by 5 is 7. Okay, 2/7 is 10/35 written in simplest form. They are equivalent. They represent the same amount. I did not change the amount of the circle that was shaded. Okay, but I've just wrote it in simpler terms. Isn't 2/7 a little easier to understand than 10/35? All right, let's do a couple more where we're simplifying. 12/18. Okay, so let's think. Greatest common factor, okay? This is the one we just did, wasn't it? All right, so 12/18. What is the biggest number that divides into both? Well, 6, right? So that's going to be 2/3, okay? 12/18, 2/3, equivalent fractions. 2/3 is just the simplest form to write that. Okay? One more. And this won't be a repeat. All right, let's do 9/21. Okay? So think to yourself, greatest common factor. Okay, what's the biggest number that goes into both 9 and 21? Okay, well, it's 3, right? Okay, 5 by 3, 5 by 3, that's giving me 3/7. 3/7 is 9/21 in simplest form. All right, I think that's it for this lesson. So, good luck.